So I downloaded the recorder that I'm using now. Okay, so the recording has started. I'll cut out this part off and just upload the rest of the part. Okay, I'll also attempt to share my screen now. Just let me know once you can see my screen. Okay, so can you see my screen now?
Positive.
You can.
Yeah, we can.
All right, fine.
The screen is clear. We can
Very good, very good. All right, so let me just I'll be using the w3school.com website that was shared initially. I went through the website and I really found it very interesting. Once from time to time, I would also be using the online C compiler to run the output of whatever we do, so that as we use the W3 school to explain what we're doing, we'll then also compile codes using the online C compiler. Alright, so now the first thing is, why are we learning C? If you were able to attend the conversation with Julian, you would see that it's important we know C before moving to other programming languages like Java and Python. And for what reason? The reason why we are learning C first is because C is the basics of all other programming languages. Every other programming language is embedded in C. C is embedded in them, rather. Although C is not an object-driven programming language. It's not object-oriented, but it is quite versatile. It's used in a lot of technologies that are available today. And one of the most important and interesting one is the current technology used by NASA. The robot that is being sent to Mars is embedded with C programming. So C is able to relate properly with the computer. It's the C programming language is able to interpret itself, interpret what humans are trying to say as clear as possible to the computer. That's why C is very useful. The other programming language, C++, C#, they are just an upgraded version of C, except that, like I said before, C doesn't use C is not object oriented, but C++ and C# and the rest, they are object oriented. That's just the difference. And a few syntaxes are different because of that. Alright, so we're not going to do this because we already have our sandbox that we use to code C directly, so we don't need to install. Yeah, so let's start from here. Alright, so this is what coding in C looks like. So I'll go to the online compiler now and try to explain everything we have on the compiler. I'm sure you can see my compiler screen.
Very well.
Good. Alright, so what's happening here? Now we have someone just came in. Let me admit the person. Okay, so we have this first. This is a statement. This line 1. Line 1 is a single line statement. Now for the statement that we normally use to code, we use the multi-line statement, where we have a / and 2 stars, and then we'll go to the next line. We're able to type whatever I want to type. That's a multi-line comment. We'll come to that shortly. But this is a single line comment. If I press enter here, I'm not going to be able to write the comment. You see, the color doesn't change, which suggests that I'm not writing a comment. The compiler is expecting me to write a C program. Now, why do we have this #include? Now, this #include is used to put in all our libraries. The most useful and important library is the stdio. And what does it stand for? It stands for standard input output header. That is the standard input output library .h, which shows is a header file. The .h here represents that this is a header file. But what this stdio stands for is standard input output library. Now another library we can have, or that we can include, is the std library. Do you remember this one? I think we use this one too in one of our codes. Now this standard library too has its own usefulness. There are a few syntaxes that are in the standard input output library, and there are also syntaxes in the standard library that is not in the standard input output. Another header file we can include is the time. You remember in one of the projects that we did as well, we also used the time. So time.h is also a header file that is used to import time, so that you can use the time syntax in your code. If you do not include this header file time, you cannot use time in your code. So it means you cannot time your code. For example, now when do we use this time? Take for example, maybe you're trying to allow your users to get few delays. Take for example, when you want to use the POS machine, when you input your PIN and you press enter, you notice that it's not immediately that you get the next page. There is always a small waiting time. So that little waiting time, although affected by internet connection as well, is just the work of the time.h. For example, when I made some Python codes, there was a time I made a guessing game with Python, and I didn't want the outputs to just appear immediately. Like maybe a user inputs a value, I would allow a little delay in between the time that the user imputed the value to when the output comes out, because I want the user to get a little delay. If you are just getting the responses, you won't enjoy the game. So you should have like a little delay, so that you like a suspense to help you see that, oh, is my number correct, or not. So that little delay is just incorporated by this header file time. Now let's move to the body of the code itself. Now int main is a function, int main. Now all your codes must be embedded in this function. Main is the name of the function, and int here is telling us what your function is supposed to do. Sorry, not telling us what your function is supposed to do. It's telling you what type of function you're trying to call. Now most of the time we would often use the int main because integers are easy to, we have the ability to quickly adjust integers. We can use a simple word to switch an integer into a string. I can print the number 5 as a string, but I cannot print the string s, for example, or the character a as an integer. But I can print the number 5, 6, 7, 8, 9, 10 as a string. So that's why we often use integer, because it's the easiest to move around, to make changes to. So now take note, the name of the function is this main. Now inside this bracket, most times you see the word void. Can anyone tell us why we have to put void in here? Anyone? You can just unmute and go ahead.
Because we are not supposed to put any function.
Okay, now
we are supposed to put after the curly brace.
Thanks for your response. Now inside this bracket, I can have what I'm supposed to have are arguments. I'm supposed to have arguments inside this place. Now, what do I mean by arguments? I can have maybe chassis is an argument. I can have int num1, that's an argument. I can have star s, that's another argument. So arguments are what you should have inside this bracket. So if I do not put anything, if I just write the word void, it means this function called main is not supposed to take in any argument for it to complete its process. So it means my main can run without taking in any argument. That's why we sometimes do not put argument. It also means that I do not want to specifically specify an argument that should be taken by this function. It means on its own, this function can run without depending on any argument. But if I put in an argument here, this function would not run unless I provide that argument. So that's why we put void. Void tells us that, okay, I do not need to supply any arguments for this function to run. Or if we leave it empty, it means I do not need to supply anything for the function called main to run. Now if I change the name of this function to, like, say project, the function name has changed from main to project. However, this code will not run. Can someone tell us why this code will not run, even if I run it with this here? If I write int project and I run this code, why would this code not run?
Because of the header. The header doesn't contain project.
Good. You are very, very correct. Now, the name or the function name called project is not located in any of my header file. So, irrespective of the name that is here, the program, the function would not run. But if I return the word main, yes, main as a function name has the ability to run this process because it can be found in one of the headers that I have included. For example, in my stdio, I can find the main function inside. So it has the authorization to run whatever task is contained in the body of the function. Are we flowing?
Yeah.
Now that is why in some of the tasks that we have done, we were told that we should create a header file called main.h, and we should include all the prototypes that we have inside. And you'll notice that some of the prototype names were void underscore is upper, void sum underscore, different prototypes were included inside the header called main.h. That is to allow those function names to be able to call or to perform the task that is located inside their function. Am I making sense? Now the printf statement here, is a standard syntax located in the standard input and output header, and the return statement too as well can also be located in the standard IO header file. So this code now would run successfully as hello world because the function name main has the ability to perform the printf command because it has taken permission from the stdio.h. So this is what it simply means. Let me just explain in clear terms. Let's say you go to a club, and in order to be able to enter into the club, you need to put on shoe. If you don't put on shoe, the bouncer would send you out. But if you wear shoe, the bouncer will allow you in. So the function main is the stdio.h is the bouncer that stands at the entrance, because the printf is a syntax inside the standard input output header. So in order for us to be able to access this printf syntax, main is like the shoe that we put on in order to be able to access the club. So main gets us into the club, then we have access to all of the activities in the club. So main gets us into the standard IO library, and then we are able to access all of the syntaxes located inside that library. I'm sure that makes proper sense now. So let's move on. I've explained everything you need to know about how the code should run. All right, so moving on now. Now this is how to print. Okay, so let's now make some little changes to the print statement and see what happens. Now, if you want to print a word on a new line, let's say I want to print the hello statement on a new line. So how do I do that?
//
I can put a \n here. If I run this, hello and word gets printed on the new line. Let me close up the gap between the slash n. Okay, so once again, now you see that hello, then the next word gets printed on a new line.
I can't see your screen again. No.
Oh, you can't see my screen again?
Came up now.
We're
It
only
just came.
seeing.
You're only seeing what?
You can see it now.
You can
You already share.
Okay, let me stop sharing and reshare.
No, it's showing now. It's showing now. It's showing
Oh, it's
now.
showing now. Okay, fine, good.
Yeah.
Okay, if I put another slash n, let's say I put another slash n here, I'll get 2 lines. Do we see? Okay, now there is a special syntax called we have slash t. What does slash t do?
Create a tab.
Yeah, it puts a tab. Slash t puts a tab between the 2 words. That's the space you're seeing here. Puts a tab. Okay, so those are just like special printing, special way to print. Okay, now let me do something interesting. Int num1 equals 6. Num1. Now, how do I get num1 to get printed? Now, num1 is an integer. So in order to get this integer printed, I want 6 to get printed. We use the percentage d.
Percentage
remember?
D.
Yes. Okay, so I have my 6 here. So my percentage d tells me that I want to print a number here or an integer here, and I need to pick the value after the comma. Okay, so
Okay, the location of the percentage D is where the symbol will, where the number will appear.
exactly, the location of the percentage d is where the num1 would appear.
It's actually the identifier.
Yes,
Of that
percentage d is
integer.
like a number, an integer identifier. But it's not only percentage d that I can use to print integers. Does anyone
Yes.
know another identifier that can be used?
I said I.
Thank you. So apart from percentage d, you can as well use percentage I, because I stands for integer, d stands for decimal, which is also like a number or whatever. Decimal, that is numbers in base 10. That's what decimal stands for, numbers in base 10. And the number we are trying to print is a number in base 10. So percentage d or percentage I is an identifier for integers. Identifier for strings, percentage s. Identifier for character, percentage c. Identifier for pointer, percentage p. Identifier for hexadecimal numbers, percentage x. Identifier for octal numbers in base 8 is o, and the rest. Let me just show it to you. Let's see. Okay, that should be on no, don't go to that mode. Okay, so should be down here somewhere. Yeah. Okay, so we see percentage d for numbers, for integers, percentage f for floats, percentage c for characters, percentage s will be for strings, yeah, as we can see here. And then we have percentage lf for double, percentage d or percentage I for integers. We can as well add numbers, integers together as the case may be. Okay, let's move on. Now there is what we call, we've not been using it yet, but it's a good thing we know. We have what we call constant, like for example here, I have const int my num. Now, because I have made int my num to be a constant value of 15, if I attach this variable to another number, I will get an error. So if I use, anytime you use the word const int, const whatever, it means you want the variable attached to the variable name to remain constant throughout your expression. Let's say I use the word const here now, const int num1 as 6, and I have maybe like 300 other lines of code. Because I have made int num1 to be constant, it means throughout the entire 300 line of code, my num1 is not going to change value. It has to remain the same as 6 all through the entire coding. It doesn't affect any other thing we do. Okay, I didn't put anything here. So it doesn't change the fact that we cannot identify it. It doesn't change that. We can still identify it and use it in a printf statement, but we cannot assign a new value to num1. It remains the same all through. Okay, so we are very familiar with the operators. I'm sure we are familiar with the operators. That's plus, minus, multiplication, division. The one we may not be familiar with is this modulus. Let me just show us what modulus means. Let's run the code and let me show you what modulus means. Num1 is 6. Okay, let me just do this. Num2, num3. So doing this, I have declared how many variables?
We cannot see the other online compiler.
Oh, the online compiler, you're not able to see it.
We're just seeing it. We're just seeing it now.
It's up now. Good.
Yeah.
Now, with this singular, I've declared how many variables?
3.
Okay, fine, excellent. So I'd say num1 is 50. Num2, let me give it 2. Then num3 is equals to num1 mod num2. Okay, so I want to.
The screen is.
Oh, sorry, it's the internet.
Okay.
Okay, so say let me change this to 2 1. Sorry, just give me a moment. I'm trying to arrange this properly. Divided by gives remainder. Okay, so oh, sorry. Okay, so yeah, so this is what modulo is all about. What I did here is 50 divided by 2 gives us what? How many remainder?
0.
So what modulo does is your output is usually the remainder. So let me change this to 3 now, and if I run it, what do we see? So 50 num1 50 divided by num2, so 50 mod num2, that is 50 divided by 3, gives us how many remainder? Gives us 2 remainder. So num3 is printed to be 2. because we have two remainders. So what modulo does is it divides two numbers together, and whatever remainder you have gets attached to the number. That's what modulo does. If I change this to 4 now, so it says 50 divided by 4 gives us 2 as the remainder. Let me change this to 6. So 50 divided by 6 gives us 2 as the remainder. So that's just basically what modulo does. It gives us the output of the remainder gets attached to whatever we want. Then we have our plus plus, which is to increment. We have our minus minus, which is to decrease. So now here may be a bit tricky. Now if I have plus equal to, it means I want for example if I say x plus equal to 3, it means I want x to be added to 3 and then the value is given back to x. Let's work it out here. Let's say my num3, let's take out let me just make num3 to be equal to 0 because I already called it in the variable. So let me just say num1 plus equal to 50. I will need to change this statement. Okay. Number 1 is 20. Okay, so okay, all values get printed correctly. Num1 equals plus equal to 10. Do you see what happened? Did you see what happened?
I didn't see you.
Okay.
10 was added to 20.
Now look at it. I initially gave num1 value as what?
20.
Now the C compiler, what the C compiler does is it runs the codes line by line. So it goes to line 8, sees that okay, this guy has initialized, he has declared 3 variables as integers. He declared num1 as a variable, num2 as a variable, and num3 as a variable. Now on line 9, I declared num1 as 20. So the computer stores num1's value for me as 20. That's what it retains in its memory. It stores num2 value as 6, stores num3 value as 0. Now it's getting to line 12 and seeing that okay, this guy is calling num1 again. But this time around, what is he saying? Plus equal to 10. So computer will go, oh, this guy wants me to add 10 to the existing value of num1 and print that as the value of num1. Do we get it?
Okay.
So that's just what happens. Because already I have 20 attached to num1, it will just say, okay, so fine. Let me just add 10 to that 20 and attach the new answer to num1. Now if I change this to minus, what do you think I should get as the output?
Subtract 10.
10, good.
10.
So if I run it, I'll get 10. You're getting it. That's interesting, guys. You're getting it. If I put multiplication here, what will I get as the output?
To multiply it, that will be 40.
That's 200.
200.
20 times 10 gives me 200. Okay, what if I change this to divide?
Divide.
I get 2.
That's 2.
Good. What if I change this to mode?
That'll be the remainder of. That's 0.
Excellent. 0. You guys are super. So we've cleared all this. We've got up to modulo. Now let's go to the next one now. If I say and. Okay, what's your question now?
What is we switch there? We switch that the line 12 to line 9. Then bring line 9 to line 12.
Okay, if I take
bring num1 to line.
Okay, if I switch line 9 for line 12,
Yes.
no, because I do not have any registered value for num1, it is going to automatically pick any just a random value for me and perform the task.
Okay. 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 Okay.
But at
Can't
the
bring
end of the
it.
day, the output will be the new value. Say for example, let me just show you what I'm talking about. So if I do this now, I will only get 10 printed all the time, because like I said, the code gets run line by line. So it is the most recent assignment that gets printed.
Okay. Okay. Okay.
So this one doesn't output. It's the line 12 own that comes
Which,
out because it's the most recent
which
assignment.
means
Because
which means this particular operator follows.
it would feel as if, oh, this guy doesn't want the old value, he wants a new value.
Okay. Okay.
Okay, good. I think now these ones are boolean. They will give us boolean responses. If I put and equal to, it means I want x to be equal to x and 3, and it will print out true for me. If I now use a statement to get a true value, it will print out so these remaining ones are boolean. So x and equal to means x and 3, x or equal to 3 means x or 3. X, now this one means x raised to power 3, and then give the value to x, while this one means greater than equal to. So these ones are just boolean, except for the raised to power, which this is raised to power. So let's say I change this now to let me just make one slight change. If I give this as raised to power equal to 10, it will do. Okay, it's too much. Let me do 2. Okay, so what is it doing? Raised to power equal to 2. Should get 400. I really don't know what's. Well, maybe I think sometimes the compiler acts up. Okay, works well now. No.
Maybe there's a space in between. Your screen is hanging, Sha.
Huh?
Your screen is hanging actually.
Wait, so sorry. That's my internet. So sorry. Alright, now when we do comparison, can you see my screen now?
Yeah, we can see the site, not the compiler.
Yeah. It's the site I'm talking about. So, these ones are also used for. These ones are for comparison. If you want to compare x and y, you have to use 2 equal to. If you want to say x is not equal to y, is how you do it. If you want to say x is greater than y, x is less than y, x is greater than or equal to, and x is less than or equal to. Now, we used and or a lot in some of the tasks that we did. The 2 and here, all you're trying to say is you want one statement and the other statement to return true if both statements are true. For example, if I say x is less than 5 and x is less than 10, what I'm trying to say is if these 2 statements are true, the program should return true value for me. But for or, which is the 2 vertical strokes, it will return true if at least one of the statements is correct. While the exclamation mark before the and statement will help us to see that at least if the 2 statements are false, or if the true statements are true. If I'm supposed to get the true value as the response, I will get a false value. So that's just the exclamation mark is just to replace Then this was one of the tasks that we did when we needed to calculate the size of each of the integers. And yeah, so that's just what we need to do. Okay, so I think we'll stop here for today. Tomorrow we would continue from the if else statement. So we'll start coding if statements, explaining how to write if else statements. Then I think we'll go to for loops, and then we'll also talk about while loops. So at least with this now, we've been able to cut across all of the basics that we need to understand concerning concerning C. We now know, so when we start using logical operators, we will fully understand what we are trying to talk about. Alright guys, thank you so much for joining today's session.